So now for the exciting one, let's introduce our speaker for today. So our speaker is by the name of Poornima Muthukumar. She is a senior technical product manager at Microsoft with over 8 years of experience in developing and delivering innovative solutions for various domains such as cloud computing, artificial intelligence, distributed and big data systems. She has a master's degree in data science from the University of Washington. She holds 4 patents at Microsoft, specializing in AI and machine learning and big data systems, and was the winner of the Global Hackathon in 2016 in the artificial intelligence category. She was honored to be the Grace Hopper Conference reviewing panel for the software engineering category last year, 2023. It was a rewarding experience for her to read and evaluate the submissions from talented women in these fields and contribute to the advancement of women in technology, as well as to learn from their research and insights. She was also a committee member for the Microsoft Machine Learning and AI Data Science in June 2023 conference. She is also an ambassador at the Women in Data Science Worldwide community and a volunteer at the Women Who Code Data Science community. Let's welcome Poornima Muthukumar. You're most welcome.
Thank you, Mercy. I can go ahead and share my slides.
Yes, please.
Let me know if you see it.
Yes, we're all good.
Okay, awesome. So yeah, thank you everyone for joining today's presentation. I'm super excited to speak to all of you today on how to unlock product growth with big data, data science, and machine learning. Some of you might be interested in getting into a career either as a data scientist, as a business analyst, as a data engineer, as a technical product manager. So if you're in any of these careers, I hope that this talk can resonate with you, and I hope that you can take back something as you look for your dream job or as you're working in your dream job. I also want to thank the Women Who Code Data Science community for giving me this opportunity to share my experience. And I want to say that I'm not speaking on behalf of Microsoft, but rather sharing the knowledge and experience that I've gained along the way in my career, and the themes and messages that I bring forward are that of my own. So without further ado, let's get started. A brief look into today's agenda so you know what you can expect from this talk. First, we will go over my background so there is context on some of the things that I share. Next, we will look at how data is at the center of nearly every product you own and how that data is used to customize product to your needs, allowing companies like Netflix, Uber to build great data-driven products. Next, we'll talk about why companies need individuals who can use data to understand customer needs and what are those different data types that you as a product manager can leverage to give customers the product that they want. And finally, we will have some time for Q&A. Cool. So a brief background, I grew up in India. I spent majority of my childhood in Mumbai and then Chennai. I finished my high school in STEM. After that, I went to Singapore where I got my bachelor's degree in computer engineering from the National University of Singapore. During my time at Singapore, I also interned at Bank of America, Merrill Lynch, and Goldman Sachs as a software engineer. Post that, I went to New York where I worked with Goldman Sachs as a software engineer, building software for banking systems and capital markets. After that, I went to Ireland where I worked as a software engineer in the Office team as part of Microsoft Ireland Research Center. During my time at Ireland, I got the opportunity to travel all across Europe, so that was really fun. Post that, I came to Seattle, where I grew in my career as a senior software engineer in the Office release and delivery experience team. So my team was basically in charge of delivering Office updates that you got for Word, Excel, PowerPoint to basically all users on all platforms like Mac, iOS, Windows, and Android. So during this time, I realized the power of big data. So I decided to pursue my part-time master's in data science from the University of Washington. And I also transitioned into my career as a senior technical product manager at Microsoft. A fun fact here is I also graduated from my part-time master's while being pregnant with my first child, who's now 9 months old and who keeps me really busy. Today, I'm a volunteer for the Women in Data Science Puget Sound community as an ambassador. I also am a volunteer at the Women Who Code Data Science community. I have 4 patents in Microsoft in AI, ML, and Big Data System. And I also volunteered at the UW Foster School as a product management accelerator. Cool. So here I have 5 products that I want to talk about how these companies are basically leveraging data to build their products, right? So first we have Netflix. We all know how Netflix uses data to build amazing recommendation algorithm, all the movies recommendation that you see, but they also use data to decide where their money should go in for what kind of content they want to produce based on what's resonating with users, what is trending. So that is something that they use data for. They also use data to decide what kind of movies they want to store in which CDN location, so that they can stream movies efficiently for users in different geographic location based on CDNs which are close to users. So this is some ways that Netflix uses data to customize their product. Next, we have Tesla. So we all know that Tesla uses data for driving their autonomous driving system. They also have different cameras and sensors that is constantly sending data to Tesla back, which in turn is used to optimize their autonomous driving system. Amazon is one company that uses data throughout their entire product stack. So they use data for their recommendation. When you search something on Amazon, what kind of searching algorithm that they want to use for powering the search result. They use for price prediction. They use for inventory management, warehouse optimization, just many ways that Amazon uses data because they have such a huge customer base. They can use all that data in turn to continuously improve their product and give value to customers. Instagram again is a great example. All the content that you see on Instagram, your reels, your homepage, your stories, everything is powered by a machine learning model that is constantly running in the background. It's taking all your usage data, it's taking all your engagement data to see what are your preferences, what is your liking, and in turn shows you content that will resonate with you in order to keep you in their product longer, in order to keep you engaged with their product. So that is one way that Instagram uses data. Microsoft 365 again has an AI, now integrates with Copilot AI, which integrates with all the different Microsoft 365 products to optimize your productivity suite experience and in turn help you be more productive and achieve more with Microsoft products. So if you see all these products, what is common to them is they have a huge customer base. They generate a huge amount of data. And today, storage and processing in computers become so cheap that you can store all of this data and extract insight, which in turn can be used to drive product growth and innovation. So let's say you join as a product manager for any of these companies. You're constantly getting signals from various channels, various sources. Could be feedback channel, could be usage channel, could be adoption channel, purchase channel. So how do you as a product manager take all of this data, huge amounts of data, and organize it in a clever way using data science techniques, data science algorithm that can in turn give you insight about your product, which you can use to grow your product and in turn grow your business, because that is what companies care about. So now, see, we have seen how all the products these days are so data driven. So the melding of data science and product management is the future of technical product management. So what you will see in this talk, in today's talk, is how to build data driven products backed by insightful analysis and how to utilize big data, data science, and machine learning to inform complex product decisions. So here I list 7 techniques that I use in my day-to-day job to drive product growth. First, I list the 7 techniques, and then we'll go in detail into each one of them. So what is funnel analysis is how do you look at your customer journey end to end to understand where customers are dropping off in order to optimize conversion. So let's say you have a website, 100 customers are coming to your website. Of that, only 20% completed purchase. So you as a product manager want to know what happened to the rest 80%, so you can really use that to optimize conversion for your product. Next is retention. Retention is a very important metric for nearly any product, right? It's great to have customers sign up, but you want to know how many of those are you able to keep with you for a long period of time. Either customers love your product or they absolutely don't like your product, right? So how do you as a product manager measure retention, measure churn? And for a subscription service, you want to know what percentage of customers renewed their subscription versus what percentage canceled their subscription. So how do you measure and improve that? Next is segmentation analysis, is how do you slice and dice your customer segment based on different attributes of the customer. Could be their feedback, could be their usage, could be different signals that they've given you, or could be their demographics, could be age, gender, income. Based on all of these preferences, how do you divide your customers into different segments, which will help you identify your most profitable segment, and in turn you can target your product differently to each customer segment and improve your product. Next is engagement analysis. This is how do your customers interact with your product, and how long do they interact with your product? How often do they interact with your product? How deeply do they interact with your product? So all of these signals will help you optimize your product's experience and in turn improve customer satisfaction and loyalty. So let's say you have a e-commerce website and you notice that majority of your customers are leaving your product within the first 10 minutes, right? So that helps you understand that a very important metric, that majority of your customers have a very short session duration. Unless you measure it, you wouldn't know. And now that you have measured it, how do you use it to improve engagement for your product? Next is feedback analysis. This technique will help you collect and analyze feedback data of different types, like for verbatim, could be ratings, could be reviews, could be comments, all of the different feedback data that you get. How do you use it to understand what is your product strength? What are the good things that customers have to say about your product, and what are your weaknesses? What is something that customers don't like, and how do you measure it, and how do you analyze that data to extract insight and in turn continuously keep improving your product? A/B experimentation. A/B experimentation is when you show two different versions of your product. You assign users to two different variations randomly, and then you measure what is it that you care about, and then you use data-driven decisions to eventually launch the change to basically the entire population of your product. And finally, machine learning. Machine learning is a very important technique that as a product manager you can leverage to drive innovation and give customers user-centric products. It's very important for as a product manager for you to have a basic understanding of some of the machine learning algorithms, methods, and techniques, so you can collaborate effectively with your data science team, with your engineering team, to partner to build differentiated customer experiences that in turn will drive innovation and business growth for your company. So, of these seven signals, some of them are leading indicators and some of them are lagging indicators. Leading indicators in the sense that you get these signals very early on in the product life cycle, whereas lagging indicators are which you need to have deployed the product for a certain amount of time, maybe for a few months, and have customers adopted to it, used the product until you get some signals, until you get some signal back. Maybe could be feedback signal, could be retention signal. How do you get that, and then eventually use that to continuously improve the products, which is why I divided them into leading indicators and lagging indicators. So now we will look at these signals one by one and see how we can use them in our job as a product manager. So first is funnel analysis. So what is funnel analysis? Is a method used to analyze the sequence of events leading up to a point of conversion. So funnel is basically your entire customer journey. How do your customers use your product? So let's say you have an e-commerce website. Let's look at one customer journey, right? So the customer visits your website, the customer wants to purchase something, so the customer searches for a product. The customers did view the product details page, added the product to cart, went to checkout, entered their payment details, and completed purchase. So this is what the entire journey looks like for one particular customer. But not every customer will follow the same journey, right? Some maybe will come to your website, they'll view the product and then they lose interest and they go. Some will come to your website, view the product detail, maybe they like it, they add to cart, at which stage again they'll drop off. Only a small percentage will eventually go on to the purchase completion stage, where they'll enter payment details and they'll complete purchase, right? So you can think of it like a funnel. The ideal journey is like the whole thing. You want every customer to go through all the different stages, but customers keep dropping off at different stages, which is why the funnel keeps getting shorter and shorter. And if you, as a product manager for your product, viewed the data as a funnel, you can use it to see where customers are dropping off and then eventually brainstorm solutions. So for this e-commerce website, if I notice that majority of customers are leaving at the home screen itself, then maybe I can hypothesize that the page is too slow. So customers are losing interest and they're dropping off. Whereas if I see majority of customers are leaving at the payment page or the checkout page, then maybe I can hypothesize that the pricing on my website is too expensive, or maybe my competitor is giving a better price. So once I have these different hypotheses, I can run experiments and then see which of them actually results, and then run experiment to see maybe one of them could result in better conversion and in turn continuously improve my product. So which is why if you had this data, you can see what the customer journey looks like for your particular product and what your particular area that you own. Cool. So next is segmentation analysis. Segmentation analysis basically gives you insight into the landscape of your product, right? Revealing customer characteristics, which can be in turn used to group customers with a common behavior or common pattern. And that again is known as clustering. You can use clustering algorithm to segment your customers. And we'll look at some of the examples. So here you see a 2D scatter plot. The different points on the scatter plot represent your customers, and here I have used two dimensions. So one is income and one is age, right? So if I were to segment my customers based on income and age, I would see some five unique segments, five unique clusters. Some of them are obviously outliers. They can extreme points. They can be attributed as outliers. Whereas you see here, there are four different clusters. So the blue one, maybe they represent students, right? They are younger in age. They have lower income. Maybe the middle segment represents techies, right? So they have somewhere in the middle, but they have a relatively higher income, followed by executives who have a super high income, and then followed by retired folks who are somewhere at a much higher age. So this is some technique that you can use to group your customers and thereby identify who's your target population. So why is segmentation analysis important? It helps you identify comparable purchase behavior and in turn helps you target your product and features based on different segments differently. So typically customer segmentation, you could, if you don't have any other kind of data, you can just use customer data and demographic data. What does customer data include? It could be like products purchased, amount spent, time purchased, product frequency. Whereas demographic data could be something like age, income, gender, education level, qualification, things like that. Of course, you can use a lot more different variables if you had maybe what kind of feedback they gave, maybe what kind of support, maybe what kind of language the customer speaks, things. Of course, you can use n number of variables here, but you could always start with something like this to identify who are your most profitable customer segments. Okay, so let's say that I joined as a product manager for this chocolate company, right? If I were to slice and dice my customer segment based on income, age, gender, and country, what would I see, right? Of course, not every customer will buy the same kind of chocolate. Maybe the ones that are higher in income, they can afford Lindt. Maybe younger generation, maybe kids, we can see that they prefer Hershey's. So once you start segregating your customers, you'll start to see these patterns surface, which you as a product manager can then leverage. Maybe you want to target your email marketing campaign differently. Maybe you want to do different promotions for different customers differently, right? So once you have this, you can, of course, even think of new solutions that you want to launch for different customer segments differently. So this is how customer segmentation helps. In my opinion, it really is very effective in answering two very important questions. One is which product would best fit a customer based on their characteristics and how to effectively market the product to a particular customer. Next, okay. Next, we have engagement analysis. Depending upon your product, your engagement metric that you want to track for your product will be very different, right? Depending upon the product, it will vary from product to product. So here, let's look at some examples for engagement metric for some very popular products that we know, right? So first is social media like Instagram and Facebook. How do they measure engagement? They want to measure engagement based on number of likes, based on shares, posts, comment, time spent. So these metrics could in turn mean translate into engagement for the company, and thereby companies might want to track these metrics every day, every month, every year to see how the product is doing in terms of engagement. Similarly, search company like Bing and Google, what do they care about? Number of search terms, number of search queries, number of page visits, right? So this is how Google would want to compare it to Bing. Now that ChatGPT is introduced, maybe Google might see a drop in engagement for if they were to track these metrics. So how do you, as a product manager, if you had access to all of this data, could then think about different solutions you can incorporate to improve engagement? Next is Netflix and Amazon Prime. Their primary engagement is the amount of time that a customer spends watching movies or watching shows. So, number of views, time spent, favorites, number of likes. Similarly, if you were an e-commerce company like Amazon and Walmart, you care about products viewed, products added to cart, products purchased, right? So the basic idea behind sharing here is that if you as a product manager were to track engagement, there is no one metric that you can use to track engagement. It varies from product to product, and you as want to identify what is that unique metric that really translates into engagement for my particular product, and then measure it, track it, and then use it continuously to to make improvements. So user engagement is nothing but it indicates how often customers use your product or how passionate they feel about your product. So there are two generic metrics that you can use to track engagement. One is unique daily active users, and the other one is unique monthly active users. So they, of course, indicate engagement day over day, month over month, and things like that. I also want to say that some companies, some people confuse that, oh, maybe I could use these metrics to also track retention. So engagement metric does not translate into retention. So we can see this example here. On October 1st, you had 3 unique users who came to your website. On October 2nd, one of that user came back from the previous day and you had 2 new users. So even on October 2nd, you had 3 users, but the retention is not improving. Retention is not improving in the sense that you're not having the same customers coming. You're getting some new customers. So even though daily active user is improving, retention is not improving. So similarly, on October 3rd, you see 2 of your previous users came, but you had 2 new users who came to your website. Similarly, on the 4th, you had 2 previous users and then again 2 new users. So maybe your sign up rate is increasing, maybe new users are signing up, but previous users are not coming back into your product again and again. So daily active user does not translate into retention for a product. Similarly, monthly active users also does not translate into retention for a product, in the sense that month over month, you could be seeing more users signing up for your product, but it doesn't mean that you're able to retain a lot of them into your product each month. So a better retention metric, if you were to use the engagement metric for retention, it's DAU over MAU. So even though you see that DAU could be going up, even though you see that MAU is going up day over day, month over month, DAU over MAU will not go up if your retention is not doing good. So you could use that metric instead to track retention for your product. Cool. So the next one is A/B experimentation. Here I have 2 different greeting cards, right, for Christmas. Maybe one of them resonates more with the users, and I see that majority of users clicking on it, opening the greetings, and then viewing the greeting card. So now this is a very trivial example. Of course, I it doesn't really matter if customers open the greeting card or they see it or they don't see it. Doesn't really translate much for the business. But this is not always the case, right? Whereas if I had a website where I wanted customers to click on the open house button and then sign up for the open house so that my house is eventually sold, I really care about what does it look like, whether the customers are inclined to click on it or not. Here you see on the left the blue button versus the orange button. Maybe customers, I see that if there is an orange button, I see higher number of signups for open house. Whereas if I see a blue button, so not just in terms of visual elements like the color of the button or the image that you have on the site, you can also use it for testing different search algorithm, right? So the one on the left, there's a different search algorithm that's powering the search ranking for the shoes when you search on the Nike website. Whereas on the right, there's a different search algorithm that's powering the search result. Maybe the algorithm on the left is resulting in higher units sold, is resulting in higher revenue come for the company. So what I want to highlight is that A/B testing is not limited to visual elements, colors, and images and things like that, layout of a page, but you can also use it for testing different algorithms, backend algorithms, different APIs, different system stack, and things like that to eventually optimize your product and eventually optimize customer experience, because that's the end goal at the end of the day. So what is A/B testing? Is nothing but it's split testing, bucket testing, randomized control experiment. It's typically used to compare different versions of a website, but you can test anything from the color of a button to the backend algorithm to the layout of a page. So you have something called as a control group and a test group. So group A and group B. And typically all elements are held constant except for that one variable that you want to test. So it's very important to have that one thing constant and measure the outcome, such as which one has a higher conversion rate. So if you were to change 2 or 3 things, you wouldn't know which one actually contributed to resulting in higher conversion. So which is why it's important to have one change that you are doing throughout the experiment. And it's the best scientific way to establish causality with high probability, in the sense that you can conclusively say at the end of experiment, based on data, based on evidence, that doing this change will result in higher revenue, result in higher units sold, because you're not going by gut instinct, you're not going by a feeling, you're not going by what you think might eventually result. You're actually going with a scientific way to prove your point, right? So what are the different A/B experiment stages? So First is defining the problem statement. Next is defining the hypothesis, designing the experiment, running the experiment, and interpreting the results. So let's look at each of these stages a little bit in detail. So again, similar to when we looked at engagement metric, your problem statement, depending upon your company and depending upon your product, will differ. And in turn, the experiments that you want to run will also differ, right? So let's look at some of the examples. So if you were a travel company like Expedia or Booking.com, your problem statement is the goal, overall Uber goal of the company is to increase number of bookings. Maybe it would be to increase loyalty programs. Maybe it could be to increase search. So based on these Uber goal, you will eventually cater your experiments to so that your results ladder up to these Uber goals, right? Uh, Similarly, if you're a media company like Netflix or Amazon Prime, your goal is to increase engagement, increase subscription rate, increase content consumption time. So eventually you'll cater your experiments, you'll make some changes that you eventually want to impact these metrics. Similarly, if you are an e-commerce company like Amazon or Walmart, your goal is to increase products viewed, increase products added to cart, resulting in higher conversion. And finally, if you were a social media company like Instagram or Facebook, the goal is to increase engagement, increase revenue through advertisements and things like that. So these are some high level problem statement depending upon your problem scope. And eventually you want to define these problem statements very clearly before you go into designing your experiments and running experiments, because you want to know what is it that you care about, what is it that the company cares about, and how does your experiment eventually translate into results for these problem statements, right? So next is hypothesis. So a hypothesis in an IGB experiment is nothing but a testable statement that predicts how changing something will impact a certain metric or user behavior, right? So I like to define hypothesis using these three-step process, right? So first is you have this problem based on evidence, and you believe that doing some change will help you achieve some outcome and thereby improve the problem at hand that you started off with. And you can do that, you can conclusively say that you've achieved your outcome when you see some metric change. So let's take one example and see how you will break down your hypothesis into these three statements. So based on evidence, based on sales data, you know that you're selling lesser number of units on your e-commerce website, right? So that is the problem. You're starting off with the problem based on your sales data as evidence. You have a hypothesis, you have a gut feeling, you have an instinct that adding X number of people purchased in the last 24 hours will create a sense of urgency and force the users to add the product to cart, to finish purchase quickly so that the product doesn't get sold out or the product is not purchased by someone else, and thereby encouraging buyers to convert, right? So that is your gut feeling, that is your hypothesis you're starting off your experiment with. And you know that you would have achieved this outcome if at the end of experiment you saw revenue increase or if you saw units sold. So you want to define these three hypotheses before you start off the experiment, before you run it, because you want to be clear on what is it that you want to impact. Next is designing the experiment. When you're designing the experiment, you want to define what is your key metric. You can have one metric, but you can also have more. Maybe in this case, our metric is revenue per user per month. And then you determine the population for your experiment. Are you running it for all users? Are you running it for a subset of users? Is it just USA or is it just Europe? Similarly, you want to determine the sample size. It's very important to determine the sample size because you want to get statistically significant data at the end of experiment to take conclusions. So you can use this formula, and there's also like websites where you can calculate what should be the efficient sample size. But the general industry standard is use an alpha of 0.05 and a power of 0.8, and then you use it to determine what should be the efficient sample size for running the experiment. And you also determine how long you want to run the experiment. You want to run it for 2 weeks. What are the seasonality, days of the week, holidays? You don't maybe want to consider, is it, do I want to run the experiment during holidays when customers are, in a different phase, in a different frame of mind and things like that? Maybe they don't come to your website so often, they are on holiday and things like that. But the general guideline is you at least want to run it for 2 weeks to get enough data to take conclusion and make evidence. Then running the experiment, once you start to run the experiment, you want to randomly assign users to group A and group B. It's very important to randomize so that there is no bias. And similarly, you partner with the dev team to instrument logging to track the necessary metric. And then you collect data and show it on the dashboard. And then during the course of the experiment, you can use that dashboard to see how the metric is doing. Maybe you're tracking revenue, so you want to see, is revenue going up, is engagement going up, are things looking good, right? And finally, avoid peeking at data to make judgments or to make a conclusion. You can look at data, but obviously don't try to say that, okay, maybe I ran it for a week, I can clearly see that engagement is going up, let's shut the experiment and let's launch it. Obviously, you don't want to do that. You want to wait for the entire duration of the experiment that you set out with and try to, jump into conclusion. And finally, once you have finished running the experiment, it's important to ensure that the data is reliable. There is the day perform the sanity check. If there is something unreliable results that you're seeing, you want to obviously discard and rerun the experiment. And finally, you want to make trade-offs. So let's say you started off the experiment measuring engagement and revenue, and at the end of the experiment you saw that, oh, that's great, like looks like revenue is growing up based on my change, I've sold a lot number of units. But maybe you see that it's bringing down engagement, so you want to efficiently track the different trade-offs and make judgment based on what you set out to do, and then eventually launch the change to everyone. So these are the different steps involved in running an A/B experiment. And based on the company that you might join, majority of companies run A/B experiments before launching a big change. And when I was in Microsoft, in the M365 team, in the Office team, we heavily relied on A/B experimentation before launching a change. So Office especially releases these updates each month to millions of users. So we obviously are very careful that we are not introducing a bug to millions of users. So the way we did it is we launched to a small subset of users. We would get all the crash signals, we would get all the telemetry signals. We would use that to then eventually get confidence and then launch the build to millions of worldwide users before doing the change. So these are some ways that you can, efficiently run A/B experiments depending on the team that you join. Cool. Next one is machine learning. Machine learning is not a magic wand. It's an application of AI that provides system the ability to learn and improve from experience without being explicitly programmed. There are many cases where classic programming will just do and will help solve the case, and you don't need machine learning for it, right? If you can just solve the problem with a bunch of if statements and just classic programming, then you might as well go ahead with it. But depending upon your problem, it could be quite complex and machine learning might be needed. So for example, what kind of search query, what kind of results you show, right? It's not possible to pre-program all the different search queries saying that if the customer searches this, show them this website, because there are just infinite number of search terms. And this is where machine learning really does a good job. So this is the framework that I use to see whether machine learning is an ideal solution for your problem. First is if you have lots of data, lots of good quality, ethical, unbiased data. So you start off with that. Next is if you're dealing with a very complex logic, like if your logic is so complex that you cannot solve with a bunch of if statements, then you know that machine learning is a good candidate here and you can use it to build an efficient solution. Next is personalization. Obviously, if you want to cater your product differently to different users like DoorDash, like Instacart, machine learning is a great example. And similarly, lastly, if your system learns with time, right? So like a system changes depending upon the scenario, depending upon the landscape of your of the time. So for example, if you take Twitter, what's trending on Twitter might not be trending tomorrow, might not be trending 3 days later. So Twitter cannot just run a complex logic saying that today show this, tomorrow show that. So they need all of the tweets data, they need all of this data to mine and extract what's trending. And this is where machine learning does a really good job. Similarly, Spotify, what's trending on Spotify today might not be trending tomorrow. And they have all of this data, they have all of this usage data, what music customers are listening to, what are they liking, and they can eventually use that to show trending songs and things like that. So if you see all of these different things you can use to see whether machine learning fits your problem space or not. So here, machine learning, I break down them into very three simple types. One is the supervised machine learning, where you have lots of data that is labeled and you use it to train the model and you supervise the model while you make it work on its own. And then you have lots of non-labeled training data, that's unsupervised machine learning. And finally, you have reinforcement learning where the machine learns on its own. So we'll look at some very basic examples of machine learning that will give you a sense of what are the different types that then eventually you can think about and brainstorm how can you use them in your product, in your space, based on where you work. So first is ranking, right? We already looked at that, how Amazon uses ranking algorithm to rank different products based on customer searches. Again, it's powered by machine learning ranking model. Then is recommendation. We also saw this, how Netflix does recommendation. It uses your past data, and then it also uses similar customers like you and what did they like to eventually recommend something for you. And the power of recommendation is it doesn't have to be accurate. As long as it's close to good enough, I think it does the job. Nobody is going to punish you if it's not accurate. Classification. Amazon has millions of products. Every day there is new company, there's new merchandise that's joining Amazon and they want to launch their product. There cannot be a human sitting there and saying, okay, this is a t-shirt, this is a skirt, this is a button and things like that, right? So this is where machine learning does great. Depending upon the product that's coming into the system, it uses the images. It automatically tags the product as either a toy, a dress, or a furniture and things like that. And when a customer searches something, these results are immediately powered in their search results, and the machine learning is a perfect example which can help solve this problem. Regression is something you use when you want to predict something. You want to predict the price of a product, you want to predict the customer support volume. Here you can see an image of how machine learning is used to predict the support call volume each day. So all of this forecasting algorithm can do a great job taking seasonality and things like that into account, followed by clustering. We also saw this where we did segmentation, where we saw how uh, Spotify can use clustering algorithm to maybe group songs based on genre. And then finally, we have anomaly detection, where Chase can use that to detect some fraudulent transaction on your credit card and then use it to flag and tell the customer, hey, we noticed some unusual activity because there's a deviation from the usual pattern, right? So in all of these examples, again, if you see, it follows the same framework that I talked about. They have lots of data. We want to personalize. The machine needs to learn over time. It's quite complex. It's not as straightforward. So all of these are great candidates where machine learning fits the thing. So you can take some of these as inspiration as you're working through your product and as you are thinking about different unique and innovative solution based on your use case. Cool. The next one we have is feedback analysis. Bill Gates once said that your most unhappy customers are your greatest source of learning. So, as a product manager, you want to definitely look at what the customers are saying about your product and what are those different feedback signals and what you can do about them is what we will see in this space. So, why is feedback important? It's basically your voice and emotion and insight of your customer. It tells you everything you need to know about customer satisfaction to improve growth, drive experience, improve NPS, and in turn improve your products and services. So, what are the different types of feedback, right? Feedback come in various types, and we'll see what are they. First one is CSAT survey. All of you might have seen something like this from Amazon, where they ask you to rate on a scale of 1 to 5. Please rate your experience. So if customers don't like, they are surely going to give you a bad rating. And if they really like something, they surely give you a 5-star rating. So you want to see how your product is doing in terms of rating and what customers are saying about it. Similarly, NPS survey, NPS is also called as Net Promoter Score. And the way you calculate is on a scale of 1 to 10, the question is how likely are you to recommend your product to your friend or colleague? So your 9 and 10, the users that give you a rating of 9 and 10, they are your promoters. And anywhere below 6, they are your detractors. And the 7 and 8 are passive, so you don't really care much about them. And your NPS rating is calculated by subtracting your percentage of promoters from your percentage of detractors. So, to give you a sense, some of the products with the great NPS rating are Apple, Tesla, Starbucks. So, these products have the best NPS rating for last year. And what it really tells you is that the product is so great that you don't really need to market it. The users will market the product for you. They will recommend to their friends and colleagues saying that, hey, this is a great product, please go ahead and use it. And you want to strive as a product manager to get to that to get to that stage where your product is so good that it does the job of marketing it itself. Next one we have is customer support tickets and calls. For M365 for Office, when I was in the team, we used to get thousands of support tickets for your product. And when maybe these support tickets reveal some characteristics, maybe customers are constantly calling for support about a certain area or a certain section of your product that's quite troublesome. And you want to see that to see how can you use that data to improve. So customer support calls, chats, transcripts, all of them underlying reveal different patterns and different things about your product which you want to track and measure. And finally, social media ratings and reviews, right? People leave them voluntarily, and you want to pay close attention to both the good things and the bad things that people have to say, so you can eventually improve customer satisfaction and loyalty for your product. So here you see that there's just so much feedback signal that's constantly flowing for your product. And how can you use different techniques to extract insight from these different feedback signals? So we look at some basic techniques. First one is data visualization. So when I joined as a product manager in my team, the very first thing that I did was build a Power BI dashboard that brings together all the customer feedback data into one place. So suddenly it became muscle memory for the team to look at customer feedback data on every monthly meeting to see what are the good things, what can we improve, how what are we paying attention to customer signal or not. And as a product team, it's really important to do this. Next is sentiment analysis, right? Here you can use NLP technique to extract the sentiment of the underlying customer feedback that you get. Is the tone neutral? Is it positive? Is it customers are irritated? Are customers unhappy about the service that they're getting? So these are some, if there's a huge volume of customer feedback that you're getting. So this is one way that you can use to use sentiment analysis to extract insight. Next is categorization. Again, for Office, we used to get millions of feedback, like thousands, if not thousands. Over the year, we would get millions. It's not possible to look at each one of them. So this is where we had machine learning model that would automatically tag the feedback items as either bugs, questions, ideas, or enhancements, and it would be automatically transferred to the engineering team for triage. So the bugs would have higher priority versus enhancements and ideas would eventually flow into the product life cycle, into the product team, into the backlog for prioritization. Next is topic modeling. So topic modeling again is how do you extract high level insights from the different from the lots of feedback data that you have, right? So here, if you can see, this is a topic modeling for Netflix. So maybe customers are talking about payment, right? What maybe they're unhappy about the price. Maybe customers are talking about login, right? So maybe customers are trying to share their password between their family members and it's not working. So page load time. So these things can extract and surface some high level things that will give you a sense of what is it that your customers are talking. Similarly, clustering is again one technique that we use to cluster the feedback and automatically route them to either engineering team, product team, design team, UX team, based on different teams within the company if your organization is so big. And these are some techniques you can use to analyze and extract insights from large volumes of feedback data. Cool. So the last analysis that we have is retention analysis. Like we talked about, retention is a very important metric for any product. It measures the ability of your product to keep users active over time. So depending upon your company, your retention metric could be very different, right? So for Instacart, of course, it's a grocery delivery app. Maybe you expect customers to come to your app once a week, or maybe at max once a month, or at max once a week, where they come in and try to place a delivery order. Spotify, maybe few times a week. Airbnb, you don't expect users to come to Airbnb every day and book a vacation. Maybe once in 3 months, it's a good enough time. Similarly, exercise maybe a few times a week or once a week. So these are the different products. They denote that different engagement for a product, and these different metrics could translate into retention. So you want to be aware of what the landscape of your product is, what the usage pattern looks like, so you can effectively track retention for your product. Right? So here I say that retention measures the ability of your product to keep users active over time. So I've highlighted users, active, and time. So these are the three dimensions which you can use to eventually measure retention. And we'll look at how can you use these three dimensions. So if you were to measure retention based on the dimension of time, maybe you want to measure how of what percentage of users are coming back to your product day over day, week over week, month over month, and that gives you an insight into the usage pattern of your product and how customers are liking. Right? If a customer like Instagram, for Instagram, if users are coming back every day, few hours in the week, that engagement looks really great. Right? So that denotes retention for your product. Similarly, you can measure retention by the dimension of the user activeness, whereas what actions they are taking on the page. Are they visiting the page? Are they taking a certain action? Are they buying a product? So you can categorize these different actions and then track the performance for these different actions to see what retention looks like. Similarly, the last one is how do you measure retention for the user status, maybe based on subscription status, right? Is it a new user? Is it a churned out user? Is the user in the inactive status? Did they come back and purchase subscription again? So you can use some of these different dimensions to measure retention. So one very important technique that we use in Microsoft, that I use in my team, is called cohort analysis. That is again translates into retention, where you group users by certain characteristics and then use that to measure acquisition based on date, product type, or behavior. So cohort analysis, like I say, it could be time-based cohort, it could be segment-based cohort, or size-based cohort. Let's look at one example so that will make it very clear. So here you see for our product for 2023, we have broken down on the left axis, you see the different months, Jan, Feb, March, April, things like that. And on the right, on the x-axis, you see is different weeks, right? First week, second week, third week, fourth week. So the very first number you see for January, for week 1, I had 500 customers who purchased my subscription. Of those 500 customers, in week 2, I can see that 2 of them left. So I have only 498 that I retained. On week 3, I see that only 496 have retained. I've lost 4 customers. So basically, you are breaking the user by cohort. For the January cohort, you're tracking week over week how many customers are leaving the subscription, and that gives you a sense of retention. So the overall heat map is color coded, so you can overall get a sense that, okay, eventually I see over weeks customers are dropping off and leaving the subscription, and that gives you a sense of retention. And once you measure it, you understand how is it that your product is doing, and maybe in a certain month you launched something that customers were unhappy, that resulted in higher churn, and maybe in a certain month you did something great and that resulted in better retention. And this is how you can track how a feature is translating into retention for your product. Yeah, I think that is all I have for today. And I'll pause here. I'll stop here to take any questions. Maybe you want to discuss something or anything that you might have.
Thank you so much, Poornima.
Yeah.
It's been a wonderful session.
Thanks.
Looks like we do have a question in the Q&A. Fantastic one. As a product manager, how would you be able to implement ML into your project? So machine learning, was this an expectation of your position, or was it something that you were able to implement on your own?
Yeah, so it wasn't really an expectation of my position. It's just that, like I said, depending upon the product and depending upon the scenario, if you think machine learning best fits the case, then you basically go ahead and use it. It also comes with the different kinds of problems you have solved, right? Based on your experience, maybe you've handled and solved a few machine learning problems, and that gives you a sense that, okay, you identify, okay, this problem could be solved using this algorithm or this thing efficiently, and then you go ahead with using that. So one very good thing you can do is you can read about the different algorithms, you can read about different things, and that will help you connect the dots when you are actually in your product space, when you're handling a problem for your scenario.
Fantastic. Thank you so much. I think that really clears that up. And let us know, Donna, if you would like a little more, but I think that covers that question. Here we have another one about what are the typical tools you use in your day-to-day? So you mentioned Power BI. It looks like you do a little Excel. Are you using SQL, another database? What types of machine learning technologies do you use?
Yeah. So I definitely use a lot of SQL, Power BI, Azure database, Azure, things like that. So typically, I don't run a lot of machine learning algorithms and models myself. When I was a software engineer, I would do that. But today, I just partner with the data science team. I just define the problem space. I define what models we want to run. I define what kind of problems we want to solve, and they are the ones who do it. Yeah, but typically as a product manager, I leverage a lot of Excel, Power BI, SQL, things like that for data analysis and visualization. Great question.
Yes, thank you so much for clarifying for that for Larry. Let us know if you'd like a follow up to that, but I think we've finished that one off. And another question here, would the experimentation period depend on product or feature, or is 2 weeks a standard period?
Yeah, I think, like I said, the experimentation window, the minimum is 2 weeks. But typically, if you see most of them experiments, they run for 2 months at least to get some data. But the experimentation, how long you run it, also depends on the sample size, like how many customers you want the customers to use the product so that you get enough data, so you can eventually make a statistical reasoning of your data. So 2 weeks is not the 2 weeks is I say is the minimum, but ideally you want to at least run it for 2 months, and typically maybe even longer depending upon how big a user cohort you need to eventually extract insight.
Awesome. Thank you so much. And we have a final question here. As a physics undergrad, what will be the best option to have a career in data science? That's a loaded
Yeah.
one, but
Yeah. I really think that today, although it's a loaded one, I today see a lot of folks in data science who are not necessarily from data science background, right? So you could be you could be someone who's really good at math, you could be someone who's really good at statistics, you could be someone who's really good at logical reasoning, and you can eventually learn these things maybe through an online course. Maybe you want to do like a part-time master's, like a short 1 year course or some online program on either Coursera or Udemy and things like that, where you have picked up the skills and you can totally go into a career in data science as a product manager. So I don't think that your major should like be a limiting factor. It should be how passionate you are, how much time you're willing to learn, and how much time you're willing to learn and grow into this field.
thank you. I couldn't agree more. There's so many different career journeys, and we always get questions like that, and the conversation is never ending on it. But definitely as many different options as there are for your undergrad, I'm sure that you can have the same amount of options for your journey into data science. I did have one question real quick, if we can just use the last few minutes. Yeah. I was curious about the requirements for product management. I'm seeing a lot of product managers these days with data science backgrounds, and based on your presentation, it makes a lot of sense why. Do you commonly see people leapfrog from data science into product management or vice versa? And can you maybe elaborate like on what skills per se in data science are the most helpful? You mentioned a lot of machine learning, solutions you come up with that you kind of pioneer for your projects. But like specifically, how technical really should you be?
I think there's no one answer. So when I did my data science masters, when I was graduating, I had few folks who really wanted to be very hardcore into data science, who wanted to be on the machine learning model building. They wanted to be a data scientist because that's where their passion lies, because that's where their interest lies, right? Whereas I had few folks who were really interested in being a product manager because they wanted to have like a breadth of experience, because they were someone they were really good at like dealing with the end-to-end landscape of a product. And data science really just is a small segment of your career. It's not the entire thing, right? So today as a product manager, the way I look at data, the way I analyze data, the way I use my data science techniques, it doesn't fill up my entire day. It's just something I do to become a better product manager. So I think the skill set that you use as a technical product manager are mostly like data visualization. Like I said, you're building Power BI dashboard for your team to track metrics. You're looking at SQL data to drive a lot of these analysis, and looking at data to extract insight. So I think, of course, it's you don't have to be super technical, but if you have a data science background, you're someone who can connect the dots and eventually come up with solution that can, help in this space. I hope that answers your question.
It certainly does for me, and I'm hopefully that helps our participants out as well. And we can always continue this conversation on Slack as well. Don't be shy. If you have any other questions, you can always feel free to reach out to myself, and we'll definitely make sure this recording's posted for everyone to catch up later. There was so much good information packed into that presentation. We really appreciate it.
Awesome. Thank you. Thank you so much, Lindsay. And thank you, Women Who Code Data Science, for giving me this opportunity. And huge shout out to Lindsay for partnering with me and being a great partner and driving the whole session.
We're really, really happy that you spent your time with us here. And hopefully everyone learned something that can go ahead and put right into application with their work, as they move forward.
Yeah.
Thank you, everyone, for your time.
Thank you.
Thank you.
Bye.
Bye, everyone.